The fun now. We can continue this nice discussion at Discord during the break. So everybody, welcome to the second day of SATToSE. It's really good to see that you're all back for the second day. So in a few minutes, we will start with a paper session. Then we'll have a short break. Then we'll have the keynote by Tom. We'll continue with another break. The fourth and final paper session will be afterwards. Then short break, and we'll devote some time for the hackathon results, and then we will close the event. Please keep in mind that during the closing, I will provide some information that I would like you to provide some feedback about this SATToSE that happened virtually. So keep your eyes open and look for my email after the event ends. And then I will also provide more information during the closing about the post proceedings and how we'll go from there. So that's the schedule for today. So Ali, the floor is yours. Let's start.
Okay, hello everyone. You just heard me speak. I'm a very fun person, wink, wink. But okay, I'm a postdoc researcher at the University of Antwerp. I've done my PhD there as well in software testing and mutation testing. And currently I'm working to basically try to integrate mutation testing and related techniques in practice. At the moment, we are going to have a session about evolution and dependencies. We have 3 presentations, and I hope that you will enjoy this session. The first presentation is going to be by Hagen Turner. He will talk about their work in progress on visualizing performance and evolution metrics of a software system. And he's a PhD student at the University of Duisburg-Essen in Germany. I will give the floor to Hagen to start his presentation.
Okay, hi everyone, I'm Hagen. So how do I share the screen?
There's a green button on the bottom.
It says host disabled screen sharing. So is there something that can fix this?
Fixed. You're now co-host, so you should be able to share the screen.
Ah, okay, all right, thank you so much. Okay, so I hope you can see my slides now.
Yes.
Okay, great. All right, yeah, thank you for the introduction, Ali. My name is Hagen Turner, and like he said, I'm a PhD student at University of Duisburg-Essen. And today I want to present to you the approach on visualizing software metrics that I created together with my colleagues Veit Frick, Martin Pinsker, and Fabian Beck. And the implementation of the prototype originates in a project group in our master's program that I supervised in the summer of 2019 at UDE. So visualizing the evolution of software metrics helps understanding the progress of a software development team with respect to code quality and related characteristics. Now, blending this information with performance information can provide relevant insights into crucial changes in execution behavior. In our approach, we interpret this composition of evolution and performance metrics as multivariate data and map it to a fine-grained method level. This composition is the basis for investigating our multivariate visual analytics approach that you can see here in the screenshot. It includes a visually enriched tabular representation that provides the method level details for all the metrics across time, a projection view that shows clusters and outliers among the methods on a high level of abstraction, and finally, a timeline view to find relevant temporal changes. We also implemented an interaction concept to connect the views and allow the users to explore the data step by step. And I will give you a demo of how this system works in a little bit. So Now, regarding the recorded metrics, the static data we recorded focuses on size and complexity metrics as two of the most important categories of static metrics. It's collected using Java and CSS and comprises the number of non-committing source statements, so NCSS, and the cyclomatic complexity number, which is abbreviated here as CCN. Dynamic data is gathered by running all unit tests of a project and collecting relevant metrics via Visual VM. To account for inaccuracies in measurement, we report the average over 5 repeated measurements. And for each method, we count the number of invocations and 4 temporal metrics in milliseconds. These are A method's self-time, as wall clock time and a CPU time measure, and B, a method's total time, also as wall clock time and as CPU time measure. As we are not only collecting these metrics for a single method, but for all methods that are somehow executed during the unit test, we get a set of metrics for all the methods in the project. And because we want to look at evolution, we are recording the metrics not only for a single version, but for basically multiple versions of a software project. And the term version in our context means one commit of the master branch of each project. Metric changes for adjacent versions are calculated as absolute differences for every metric. And to denote the diff variant of a metric, we use delta as a prefix to the variable name. Diffs are calculated between temporally consecutive versions in a user selection and hence represent a set of evolution metrics. And this brings us to the point where I hope that the demo will work. So can you see my browser screen now? I hope someone nods. Okay, so
yes.
Okay, thank you so much. All right, so for the demo for today, I prepared 4 versions of the Apache Commons Lang 3 project. So I will just upload it to our backend that's currently running locally on my computer. And the whole application is web-based, so it actually runs right now in a browser. And the computation happens in a Java backend that takes a bit of time. Okay, so now that the computation has been done, the first thing that we see here is the aforementioned timeline view. So we see aggregated project metrics here with the x-axis being the versions and the y-axis being 3 metrics. So it's the number of classes, the number of functions, and the number of NCSS. Okay, functions should actually be methods, so typo. You can select and deselect the metrics here and look at how these metrics change over time. So I'm going to go ahead and select the first 2 versions. And as soon as I click the second version, the computation of the projection starts. And we see all the methods and the method details in the tabular view. So as we are interested in the whole evolution, or basically the evolution over the 4 versions that are provided, I'm going to wait for the projection to select the last one. Okay, so now it's running. As you can see here, whenever I selected a new version, the number of bars in each table cell increased. So right now we have 4 versions selected, so we have 4 bars here. Okay, makes sense. So I'm going to select all the methods. And for this example that I want to show, I want to focus on one dynamic metric, that's the self-time. So I'm going to deselect all the other dynamic metrics. And I also want to have a look at at one of the complexity metrics, in this case, the CCN. And as I want to find methods that code change, that evolve in the same way, I also use one of the diff metrics. And based on these 3 selected metrics, I will run the projection again. And to reflect these selected, the metric selection, I can go ahead and choose the same in the table. So now we see a nice little projection. The algorithm here used is UMAP, so it's a JavaScript implementation of UMAP. And I'm going to order by the absolute change in complexity over the whole data set. So the number one method here is this locale utils to locale. And as we can see here, we have a nice cluster. So I want to see methods that somehow changed similar to this one. So I'm going to select the single method, and I'm going to say that, okay, give me the next nearest neighbors in projection space, and I will end up with 7 methods that show a similar evolution of metrics. And since this toLocale method dominates the scaling here, I'm going to remove it from the selection and order the methods by name. So now I can see that, okay, they all share a drop in CCN in the last version from the basically in the last version. There's a huge gap in the CCN development, and now I can see that basically 3 methods come from the string utils package and 3 come from the thread utils, not package class, sorry. The package is indicated by these colored dots in front of each method row, and the same coloring is also used in the projection view. So now I can even look at some more metrics. So let's see the total time and the diff in the total time, as well as the diff in the self time, and another evolutionary metric. Let's look at the NCSS. So what we see here is that the string utils all have a decrease in self-time, NCSS and CNN in the last step, and the thread utils have a decrease in the dynamic metrics, but an increase in the dynamic metrics, but a decrease in the static metrics. So this concludes the demo by giving you now the option. So now that you found something in your exploratory analysis, you can start making sense of it, basically. Okay, so going back to the slides. To conclude my talk, I want to quickly summarize what the work in progress character of this work means. So what I presented to you is a framework for the explorative analysis of multivariate performance and evolution metrics. And the thing is that these metrics, currently we are tightly coupled to Visual VM and Java NCSS, but as soon as you record metrics with some other tools and write an adapter to our backend, the visualization can also be adapted to that. So regarding the open questions and the future work, quickly coming back to the demo to give an interpretation of the data that I just showed you, because for the paper, I looked into possible sources for the observed patterns in the metric change. And I found that for the string utils package, functionality has been moved to a different class, and methods have become deprecated and are now only stubs that call external methods. So this explains the changes in the metrics. And for the thread utils method, the one that showed a decrease in CCN combined with an increase in total time, the source code reveals that functionality has been replaced by a generalized version that takes longer to execute. So to quickly sum up, because I guess time is running out, right now we are still looking for questions that we can answer with our approach, especially the question, why has metric X changed? So for this, I propose to have the source code one click away from you every time that you use the software, so you can actually make sense of the changes using the source code. And then, of course, the question of, are there metrics more suitable with respect to these questions? And is executing unit tests and profiling the result the proper way to gather these metrics? And one thing is the scalability of the visualization. So having way more versions and way more methods would break our current approach, so we need to adopt for that. Okay, so that concludes my talk. Thank you so much for the attention, and please ask questions if you have any.
Okay, we received a few questions. I will just go in order votes. So one of the major questions that I've seen that Maria and Tom both asked is basically what happens when you scale this to larger projects. If you have a lot of metrics, if you have many different versions, do you think this is in this form even adequate to keep, or do you think that you need to basically create new types of visualizations for that?
That's a very good question, and that's one thing that I tried to address in the scalability issue on the last slide. So I think the visualizations itself would work. So a scatter plot basically powers the projection view, and UMAP can run on bigger data sets than we have currently right now. And the tabular view would be heavily would need to be heavily changed to show more metrics and more methods at the same time. But scaling the bars or coming up with some really matrix-like visualization should give us some space to show more metrics, I think. I don't have a concrete number on how many I would think, but I would think the table as well as the scatter plot would scale. Yeah.
Yeah, and I also see that Tom is asking another question, and that's I think this is more of a comment. It's like he says, try to find more causal relationships with metrics, and then also do you do changes in some metrics in previous versions? Do changes in some metrics in previous versions lead to changes in other metrics in more recent versions? I think this is an interesting thing to investigate.
Yeah, I completely agree. These whole temporal aspect could be leveraged more, and especially, like you said, the correlation between metrics and time. Yeah, definitely something to look into. So, thanks for the comment.
Okay, we still have around 7 more minutes. If somebody wants to ask questions directly, they can raise their hand, and then I will give the floor to them.
Ali, I had another question, if I may.
Yes, go on, please.
So another question I had was, so for the moment you have your scatter plots based on clustering stuff. The question was, so other series of metrics are, for example, if you have coupling and cohesion metrics or whatever other types of things where you want to show dependencies between different software artifacts. In that case, you would need to show graphs and the evolution of these graphs over time. Would your approach work for this, or would you have other challenges in terms of scalability or whatever to be able to integrate this into your framework?
Yeah, so the whole graph thing is currently not reflected. So dependency graphs or basically dynamic graphs, so because we have the temporal dimension, these are currently not in the scope of this, and I don't see a simple way to add them to this. But yeah, it's definitely something that is super interesting when you want to make sense of the things that you found out. So yeah, that's one thing that we have to look into.
Okay, more questions? Okay, on the Discord, I see Saba ask a question about how is the analysis part implemented? Do you use SG implemented by yourself, or do you rely on a third-party tool?
I'm not quite sure I understand the question. Is it the question of the tech stack that we use, or?
Maybe Saba can explain.
Okay, I join in. So how do you calculate the metrics, basically? You use something external, because maybe you said that in the presentation, but I might just missed it.
Okay, sorry. So for the dynamic metrics, we use Visual VM. So we check out one commit of the master, we run the unit test, and we profile it with Visual VM. And then we do it for all the versions and basically save the stuff that Visual VM gave us. And for the static metrics, we use Java and CSS. So it's also just you run it via Maven, and then you get an XML output, and both combined, we pass in our backend and we map it to the methods, and then do the averaging and all this.
Okay, thank you. Thank you. It's clear.
So I see also Maria asked another question, and that's on projection view. What does the axis represent?
Okay, so UMAP is basically used in our case for dimensionality reduction. So what we give in for every method, it gets a vector that's comprised of one dimension per metric, and we chain these vectors for every version together. So for example, you have 4 versions and you want to cluster on 3 methods, you would end up with a 12-dimensional vector per method. And what we then do is we give these sets of 12-dimensional vectors to UMAP, and UMAP projects it down to 2 dimensions. And these 2 dimensions we can use to plot the scatter plot. So X and Y they are basically the projection axis. So they don't have a value that you can easily interpret, so to say.
But if there is a group that is together, basically, or within a line, it just means that these groups of classes are co-evolving, right?
Yeah. So basically, that's it. Yeah.
I do have a question. I'm sorry.
Yeah, no problem.
Go on, please.
Okay, I just looked a little bit in the paper. So you said that you do the average over 5 measurements.
Mm-hmm.
Okay, well, I have a question. Of course, why do you use 5 measurements? Why not more?
Mm-hmm.
And then the question is, of course, why do you do average as a metric? Why don't you do, I don't know, there are other measurements like quartiles, and other statistical variance could be used, and so on.
Good point. So the number why we chose 5, I don't recall. So I guess it was basically because one of the students' laptop took forever to even compute 5, so we stopped at 5, I guess. And the choice for average, that's would be something that we could look into to do something more sensible. So if you have a pointer for me where I can look, so I would gladly take this offline. And
yeah, very quick, because you want to detect anomalies, in what you have. So you may want to represent your data like it's done in statistics, like a PDF and stuff like that. Mm-hmm. And then you have something like that is called change point anomaly detection method that you can use. But I can take this offline with you. And for the number of the measurements, I would strongly suggest to do something like 30, because then the assumptions behind that the distribution is normal Gaussian, would hold them. 5 is, I'm afraid, a little bit too low, but okay. I'll take offline with you. Thank you.
Okay, thank you, everyone. If there are still questions remaining, you can take it to during the coffee table session on Discord, I assume. It's time for the next presentation. The next presentation will be by Damien Leguet, and he's a PhD student at University of Mons. He will be presenting a paper on the freshness of packages in Linux distributions. I'll leave the floor to Damien.
Hello. Hello, everyone. I'm Damien. Everyone can see my screen?
Yeah.
Okay. So I'll talk to you, as Ali said, about package freshness in Linux distributions. Let's get into it. So as we all know, Linux distributions come in a wide variety of Linux comes in a wide variety of distributions. There are hundreds of them. These are some of the most popular ones, like CentOS, Fedora, Arch Linux, and so on. These distributions have to make a choice as to what they will emphasize between several aspects. Ideally, you'd want the distribution to be really stable, to be really secure, and to always have the latest features from all the packages that they deploy. But this isn't always possible, because every time you update a package, you run the risk of introducing new bugs, of introducing new security vulnerabilities, of introducing incompatibilities with another package, of introducing breaking changes, and so on. So distributions make different choices. Some of them focalize heavily on stability, like Debian stable is the arch example, I would say. CentOS as well, because it's mostly aimed at server use, so it's less important to have new features. It's more important to have a stable environment. Some distributions are basically aimed at Richard Stallman, like CubeOS and Subgraph. They really go all the way towards security, allowing you to sandbox everything. Alpine takes another approach by being as minimalistic as possible. It's another server in distribution. And some distributions like to emphasize package freshness, which is to say, always having the latest versions of all the packages as quickly as possible. Typically, that's your rolling releases like Arch Linux, Gentoo, Funtoo, Tumbleweed, and so on. Stability and security are very well studied, but freshness, there's very little, very few papers on it. So we're going to focus on that. To do so, we have undertaken a mixed study. First, a survey of Linux users, which I will report on today. And then later on, we, in the very near future, will conduct empirical analysis to compare the freshness of packages between distributions. So the study, we distributed it in February at ChaosCon in FOSDEM. We got 68 answers, and we asked users, well, first of all, is it important for you to always have fresh packages to get updates? Why would that be? Why would you consider it important? How do you update? What mechanisms do you use? And do you perceive your distributions, the distributions you mostly use, to be fresh, to always have recent packages? For that reason, we also asked them what distributions they use, obviously. And we moved on to exactly that. So we asked them to rank up to 3. They could answer only one if they use only one. Up to 3 distributions that they use. Unsurprisingly, Ubuntu and Debian dominate the chart. Arch Linux, CentOS, Mint, and Fedora were also frequently answered. And we got a few miscellaneous answers. They could choose from a list of 16 popular answers, and they could answer anything else we hadn't listed. So for the other answers, the other questions, we divided packages into 6 categories. Open source end-user software, things like Firefox. Proprietary end-user software like Adobe Reader. Development tools like IDEs or Git or graphical user interfaces for Git or whatever. System tools and libraries like shells or even basic commands like sudo. Programming language libraries like Python or Java. Runtimes like Python or Java. And programming language libraries like NumPy for Python, Lodash for NPM, Boost for C++, any library you can think of. So for each of these categories, we asked them, in the distribution you use the most, how long do you perceive it takes to deploy a new version of a package. They could answer that it takes in the order of days, weeks, months, years, that it's never available, or that they didn't know. A few users said that they had no idea. Others had their opinion. This heat map shows the median answer when we consider days to be at one extreme and years at the other. Well, never is considered after years. So unsurprisingly, Arch Linux users perceive that it only takes a few days for the most part to obtain packages. What is more surprising are the answers we got for Debian and to a certain extent for Ubuntu, because Debian stable is not supposed to have to get new releases quicker than Debian testing. That goes against the process of Debian. Similarly, there's no reason why Ubuntu LTS would have fresher packages than Ubuntu, yet we see those answers. So this demonstrates that users do not always accurately perceive package freshness in the distributions they use. We also asked them whether it was important to them to have fresh distributions. They had 4 possible answers, and for most package categories, they consider it at least moderately important to update packages. Not so much for proprietary software, and we don't know why, because proprietary software is just as susceptible to have bugs or security vulnerabilities or to provide new features. So this might just be because it's harder or something, but for the most part, we don't know why. We also asked them why they update. Unsurprisingly, security tops the chart, because who wants to have vulnerabilities on his machine? So yeah, everyone answered security. They could answer everything they wanted, so they could pick all 5 answers if they wanted. And then bugs and new features are also frequently cited, which we would expect as well. Arch users are more likely to answer that they update to obtain new features, which goes in hand with the fact of using a rolling release. And Debian users are less likely to say, I want bug fixes, I update for bug fixes, which goes in hand with the fact that the Debian process should lead to fewer bugs, because by the time they reach stable, packages and versions of packages have been tested quite extensively. So there should be fewer bugs. Finally, we asked them how they update packages. There are 5 possible sources: using the official package managers with the official repositories, using community repositories, using third-party package managers, be it distribution-agnostic package managers like Flatpak, Snappy, or AppImage, or programming language-specific package managers like PyPy, Gem, Cargo, and so on. Or they could install from binaries if they trust the distributors to not give them malware. Or you can install manually from sources. Again, unsurprisingly, people tend to rely on official repositories because, well, they trust the distribution, otherwise they wouldn't use it. Plus, it's quite convenient to update through official repositories. Community repositories see quite a bit of use as well. There are exceptions. The most obvious one is proprietary software, because, as I was saying earlier, some distributions, or maybe I didn't, some distributions just don't deploy proprietary software. So obviously there you have to resort to using binaries or community repositories. Programming language libraries, well, they are often installed to programming language specific package managers. In fact, I think 68% that say they use the official repositories is quite high. When I install a programming language library, if it's something like Python, I'll use PyPy. If it's something like C++, I'll install from source. So it's quite high, 68% for official, but some do. And development tools also see a lot of use from third-party package managers. This is because some tools are available on Flatpak and Snapcraft, actually, that aren't available in official repositories. Like, for instance, some IDEs or graphical user interface for Git. For example, if you want IntelliJ IDE and you're using Fedora, you won't find it on the official repositories, but you will find it on Flatpak and Snapcraft. Snappy. This concludes the survey. This is a teaser on the empirical analysis that we are going to conduct. We identified a set of packages that were found in 5 distributions, the 5 most popular with users. So there are 529 packages that we identified. And we compared what versions were available in recent releases of these distributions. So CentOS 8, Debian 10, Ubuntu 19.10, Fedora 31. And for Arch, we took a snapshot that was as close as possible to the release of the other distributions to have the most comparable status. So we see that the overwhelmingly packages in Arch are at least as fresh, so they have at least the same version, maybe a more recent one, at least as fresh as all the other distributions. On the other hand, we see that for some distributions, like CentOS, only 28% of packages are at least as fresh as those in Arch. So that means 72% are older versions than those found in Arch. Gets a bit better when you go towards Ubuntu and Fedora, but still only 72% for Fedora that are at least as fresh as in Arch. So we can start to classify distributions along a continuum with Arch being the freshest and CentOS the least fresh of those considered. But we need to conduct further analyses to confirm and to quantify what the difference is. This difference fits into the framework of technical lag, which is what we're going to use. It can be counted in number of versions that are available since the one that is deployed, or in time since a fresher version has been available. So that's in the near future. What we have just done between submitting the paper to SATToSE and today, we've extended the survey. We now have 170 participants. We submitted that to IXME, and we are going to conduct a survey on the impact of freshness on user attractivity and migration. We want to see if package freshness really motivates people to use a certain distribution or to switch from one to another, if it's really that important a concern for users.
1 minute.
So, perfect. As a conclusion, users tend to consider it important to keep their packages fresh, mostly for security and bug fixing concerns and to obtain new features. They rely on official repositories whenever they can. But some distributions are perceived as quite slow on the order of months to release packages to official repositories. And indeed, we see with a preliminary empirical analysis that it's the case, but we need to conduct further analyses to really quantify and place distributions on a continuum. So that's it for me. If you have any questions.
So we have a few questions on the Discord. The first one is from Alexander, and he's asking that why do you think the proprietary software is less important to update? Is it possible that they're more stable, or it's less urgent to upgrade them, or do you think that the attack surface is smaller than OSS software, or what do you think the reason is?
I wouldn't think so. I wouldn't think that proprietary software is safer, or that the attacks. Well, the attack surface, okay, people don't see the code, so it's harder to find a vulnerability that way. But on the other, quite the opposite, I would think. We know that open source software helps identify vulnerabilities quicker. So no, I don't think it's that reason. I don't think it's less important myself. I think it's just as important to keep it updated. I think they might have answered that because it can be harder to do so. If it's not available in the official repositories, they don't do it, and then they consider it less important. But no, I don't think it's less important.
Do you think this has to do? I'm trying to basically collapse some of the comments on Discord, but do you think this has to do more with the fact that the design of the software in Linux repositories is in a way that it basically encourages upgrading OSS software rather than the proprietary software? For example, the official repositories with APT will work much more integrated than something like pip or snap or those.
Yes, exactly. That's what I was trying to get at. I think the ease and to upgrade through things like APT does facilitate that factor. Yeah.
Okay, one more quick question. If somebody wants to ask, you can ask directly here. Okay, I see some questions on Discord. Maybe you guys can take it offline because we're basically running out of time for this presentation. You can always join the coffee rooms in Discord during the break, and then you can talk to the authors and about their papers there. So thank you, Damien. We're going to move on to the next presentation. The next presentation will be by Nuria Brook Tarrega.
Yes.
She's. Wait, let me find the intro text. It's too many questions. Okay. The work will be about measuring the degree of library dependency, and Nuria is a student volunteer from Universiteit van Amsterdam. So I'll leave the floor to Nuria, and please go on.
Thank you. Okay, can you see my screen?
Yes.
Okay, great. So now I'll be presenting the work I did for my paper, which is the initial part of my master's thesis. This work is framed on the topic of dependency management, which it's been researched from many different perspectives. But in particular, I'm focusing on the detailed evaluation of the dependencies. So this is usually what the package management dependency evaluation looks like. So it's just a binary evaluation of the dependencies. Either you depend on a library or not. But it is a bit more complicated than that. And you can have different degrees of dependencies and also some supposedly transitive dependencies that are really not there. So that's what I'm working on. I'm trying to measure these dependencies. To do that, I first looked at how dependencies are measured within a project or a library. And the answer is usually coupling metrics. So the idea is to adapt these metrics to be used between projects instead of within one project. So first, I needed to create the definition of the coupling that I wanted to measure. And for that, I used this framework, which is based on 3 previously existing frameworks. And basically what it does is to create 6 criteria to specify the different characteristics of coupling that, that you're going to measure. So now I'm going to go through all these criteria. So first, we have the type of connection that we are measuring. As you can see here, there are many ways in which 2 classes in this case can be connected. For example, one class has a method that returns a type of another class. The framework defines 7 different types of connection, and I'm focusing on 2. The first one is the aggregation coupling, which is created when a class has a field which is type of another class. And the second one is when a class invokes a method that belongs to a different class. These 2 types of connection are the ones that are used the most in the literature. And in particular, the second one, it's hypothesized to be the most relevant one. So the second criterion, it's about the point of view from which you measure coupling. So you can measure it from the client element, the one that calls another one or that uses another one, and that would be import coupling. And the second one is the server element or the element that is called by another one, and that's export coupling. Since our problem statement is about measuring the dependencies of our library, we are measuring from the point of view of this client library, and therefore we measure import coupling. Then we have to decide about the granularity of the measure. First, the aggregation level at which we are measuring, which is directly given by our problem statement, which is library level. And then the way we count connections. As I said, I want to measure the degree of dependencies, not whether there's a dependency or not, or coupling. So I'm measuring each connection individually. And in order to maintain the fine-grained evaluation, what I do is to measure it at the lowest level. So for example, for method invocation, that level is method, and then aggregate it per class and then per library to get to my aggregation level. Then the fourth criterion is about the stability of the server. This is basically created to distinguish between the classes that are part of your project and the classes that are not. So what we do is measure connection from unstable classes, the classes of our client library, to stable classes, the classes of our server library. Then this criterion, it's about deciding whether your metric accounts or not for indirect coupling. And in our use case, we have 2 main scenarios. The first one is measuring the direct dependencies between library 1 and library 3, for example, and then the transitive one between library 1 and library 5. Although I'm going to work on both of them in my thesis, for this initial work, I focused only in the direct dependencies, and therefore I measure only direct coupling. And finally, let's talk about inheritance. This criterion treats all the different special cases that are related to inheritance. So the first one is inheritance-based coupling, which is the coupling created when a class uses a class that it inherits from. So for example, in this case, if class B would call a method on class A, this is sometimes treated as a special case by the literature. But in this case, we decided to account for it, so also consider it, but together with non-inheritance base without making any distinction. Then we have to decide whether our metrics are going to account for polymorphism or not. So if we look at this very simple diagram, we could have an object of type class A and call MB on that object. But this object can really also be class B. We don't really know it for sure. So both methods, we have two different implementations of this method, could be executed. So this method call would create coupling with both classes. So we are accounting for polymorphism. And finally, we have to decide what makes a method or an attribute belong to a class. And what we've decided is that a method belongs to a class, the class that implements it. So for example, if we have an object of type class B and we call MA on this object, we would create coupling with class A really, because it's the one that contains the implementation of MA. If this method invocation would be to MB instead, this would create coupling to class B, since that's the one that contains executed implementation. So with all that, we have two different metrics. The main difference between these two metrics is that one counts method invocations and the other one counts this aggregation coupling. Both of them are measured at the lowest level, so method level for method invocation and class level for aggregation, and then aggregated to the library level. And then for the accounting for polymorphism, for the first one, we count all the polymorphic implementations of the method. And for the second one, we count the descendants of the class that's being used. So with this definition, I created a proof of concept implementation to calculate these metrics with some example libraries. And my initial results are basically these calculations. So here we have an example. We can see that most of the time there's more method invocation coupling than aggregation coupling, which intuitively makes sense, with a very clear exception of the Creo library. I've looked into this one specifically, and I realized that there's so much aggregation coupling because the classes used from this library have a lot of descendants, so that increases its value a lot. And also we have one example where we find aggregation coupling and not method invocation coupling, which is the library Fling metric score. So what we've done until now is to formulate these two coupling metrics and be able to measure it, to learn a bit about the behavior. But there's some next steps that we have to do. First of all, to define the metrics to measure also transitive dependencies, and then to validate these metrics. To do that, we have two different approaches. The theoretical one, in which we define some properties that the metric should fulfill according to what they are measuring. And then the empirical one, in which we compare the development effort or maintenance effort with the value of our metrics, to have some certainty that these metrics are really a good indicator of what we are measuring. And finally, my thesis has a second research question, which is related to estimating the effort that you would need to replace a dependency in case the library that you're using has a vulnerability, or it's not maintained anymore and you just don't want to use it anymore. So that's it for me. Let me know if there are any questions.
Okay, thank you for the presentation. I see one question on Discord, and that's from Tom. He asks whether you intend to study hidden or change coupling.
I'm not sure what he means by
maybe
that.
I can explain.
Yes.
So sometimes it could be that two classes or two methods are coupled, but only implicitly. So there is no single technical dependency between them. So it's not that one method is calling the other, but still they are coupled in the sense that, for example, if you look at the evolution over time, if one method is being changed, another method that is seemingly unrelated will also be changed at the same time. So there is some kind of implicit coupling between these two methods. So this is also something, this type of, well, there have been different terms being used for this in the research literature. Some call it change coupling, some call it hidden coupling. I think this will also be interesting to study. Of course, it first requires you to detect this kind of implicit or hidden coupling. But then I think you could, in principle, use the same type of approach as what you're proposing.
Yes, I'm not doing it right now, but it is really a nice point, and it would be interesting. Although I initially discarded it, sort of, because, well, I think that's also related to evolution coupling, which, for what I've seen, it's mostly used to detect coupling within a project, since, I mean, makes sense because it's developed by the same team. But yeah, it could also be applied to this case. Thank you for your suggestion.
Yeah, because even if you have like projects, it's not, you might have a team that is developing multiple projects simultaneously. And in that case, it's also possible that different methods in different projects are changed simultaneously, even though there is no single relation between them. Simply, maybe just because of copy-paste reuse, and they see a bug in one method in one project, and they fix the same method in another project, then you would probably also observe this. I don't know if it's frequent. I have not seen any research on this even. Maybe it existed, I'm not sure. It was just an idea.
Yes, thank you.
And Tom asked another question as well, and that was whether do you think this is going to be scalable if you try to deploy it on transitive dependence?
Yeah, that's actually what I'm working on right now. So I don't have a strong answer yet, but for now it doesn't really look very difficult to scale. But I'll be able to give a better answer in a few days, probably.
Okay. Any other questions? I would like to just ask another question, if you mind. How do you plan to actually do future work on metric validation? I'm also working on some metrics myself. I'm actually curious to see the different methodologies that can be used to do that.
Yeah, sure. Well, for the ones that I presented here, I've actually already been working on the theoretical validation, in which I use the properties of coupling metrics that have also been used many times in the literature. And for the empirical one, my idea is to find some examples of libraries that have been changed many times, and then find those projects or other libraries that depend on this, and see how these changes affect the libraries that depend on it, and then measure also my metrics on these dependencies and see if there's a correlation in it, to make sure that it's a good indicator of how much you depend on a library.
Okay. So any other questions? Then if there are no more questions, I would like to thank all three presenters for their very nice and interesting presentations. We are finishing this session 5 minutes early, but that means that you have more time to spend in the Discord channels to talk to presenters one by one, or talk between each other, make some jokes and stuff like that. So I will close this session right now. Maybe Eleni can tell us about the next session afterwards.
Thank you, Ari. So let's all go to Discord to continue discussing papers or just for social interactions. You can find the voice channels there, so feel free to join any table you want, depending on your interests. And then let's get back here in 20 minutes where we have the second keynote of SATToSE by Tom Mentz. And see you all at Discord. And also, if you prefer to just mute your microphone here and stop the video and keep Zoom open, that's perfectly fine as well. So I'll see you at Discord and back here in 20 minutes then. Bye for now.
And then also everyone, has time to comb the hair and put the tie and get this suit. So, see you in a bit. Bye.
Thank you, Anna. So now we will start our second keynote, which will be given by Tom Mentz. So if you know Tom, there's not any description that can suffice to describe him. For those who don't know him, he's a full professor at the University of Mons. He's been directing there the software engineering lab for over 15 years. I've been lucky enough to be hired by Tom as a postdoc. His research evolves mainly around empirical software engineering, software evolution, software ecosystems and dependencies, and open source software health. So today, Tom's keynote will be related to those topics, and the title is on the fragility of open source software packaging ecosystems. So to the one and only Tom Mentz, I give you the floor.
Okay, thank you. Let me see if I can. I cannot share my screen. Host disabled attendee screen sharing. Okay, let me try.
Yep.
Yeah. Okay, I have to choose the one that. Which one? Okay. So we'll have to temporarily quit and restart Zoom to.
Okay, let's give some time to Tom. It appears he needs to restart Zoom.
Don't forget to use the text channel Keynote 2 on Discord for your questions and remarks. We are there to collect them and voice them over to Tom.
Maybe I can start the presentation for him, as we're suggesting here.
We're excited to see your results for the hackathon. If there's any scratching of the surface, any hero trying it out, please let us know for a quick presentation during the hackathon time.
I mean, there's another alternative. We can give Tom's slides to Kim. Kim, are you there?
I just arrived.
Okay. Tom had some technical issues, so he had to restart Zoom. And I thought that if he had problems connecting, that we can give Tom's slides to you to present.
Okay, I will randomly find things to tell.
The video will be very similar. The content is there. Oh, there he is. Okay.
Yeah, here.
Tom?
I'm back. Sorry, I had to
No worries.
reconfigure my system preferences because I installed a new version of Zoom recently and it didn't still allow screen sharing. That's why. So I can do it back again. Share screen. Okay, do you see my screen?
Yes.
Okay, perfect. So.
Your screen looks correct.
Okay, the quality is okay?
Yeah, it's perfect.
Okay, perfect. Okay, so welcome everyone. Thank you for having invited me to give the second keynote talk for the SATToSE 2020 seminar. So my talk is actually related to some of the other talks you have heard today and yesterday. So it's also about dependency management in open source software packaging systems. So before delving into the topic, this research is of course not done by myself alone. It's part of a big team effort. So here you see, well, it's an evolving team because you can still see Eleni in the middle. Unfortunately, she's no longer a member of my team. All the others, the one on the right, Ahmed Zerouali, is also no longer a member. These are two postdocs that have moved elsewhere, which is very good, of course. Maybe start a little bit with the context. All of this research has been done or is going on in the context of the SATToAssist research project. If you want to know more about it, you can see the Twitter handle and the website, SATToAssist.github.io, where you can find more information. It's basically an ongoing project related to software ecosystems involving, it's a Belgian inter-university project involving 4 different universities. On the Walloon side, University of Mons and Namur. And in the Flanders side, there is University of Antwerp and Brussels. The key principal investigators are myself, Anthony Kleef, Koen de Rover, and Serge de Meyer. So to start explaining the topic of my talk, I first have to introduce, because everything I will be saying will be about software packaging ecosystems. What do we understand by it? Essentially, it's just a large collection of software packages that are related to each other by means of technical dependencies, but also social dependencies, because they are developed by a large community of software developers. So typically we are talking in terms of like several tens or hundreds of thousands of software packages, and the communities are like also several thousands of developers contributing to these packages. So it's basically packaging ecosystems. They are using typically distributed development. So the projects are developed through tools like Git. They are shared mostly through online repositories on GitHub or GitLab or Bitbucket. And all these packages are being distributed through dedicated package managers. I will show you many examples of these in the next slides. What's also important to note is that if you consider each of these package managers and their packaging ecosystems, they have sometimes specific and different versioning and release policies, which is something that is interesting, but also challenging because your research you're doing on one of them might not necessarily apply to another one. So here you see a little bit of history on the bottom of this slide with some examples of package managers over the years. The bottom of the slide are basically Linux-based package managers. On the top of the slide, you see mostly, I don't know if I move it.
Your sound broke for a bit, Tom, but we can hear you now.
Yeah. So I asked if you can you can see my cursor if I move it or not.
Yes.
Yeah, okay. So here, for example, we see that's the different packaging. You see PAN, that's for, let me see, it's Perl, I think. CRUN is for the R language, Python. Over the years, more and more, there's more and more package managers coming as the years go by. So now basically every major programming language has its own or even multiple package managers. So package managers, they do exist for different operating systems. Any operating system has one or several package managers associated to it. Package managers also exist for different, even for specific projects, like if you have WordPress, they have its package manager for all of the plugins. Eclipse has its Eclipse Marketplace. The Atom editor has a package manager, Emacs, and so on. What I will focus on in this talk is package managers associated to specific programming languages. For the major programming languages, we took the most prevalent package manager, and we looked at those. Here you can see the number of packages in them. It's expressed in terms of millions, except for Python, where it's expressed in terms of thousands, and Java. So you see JavaScript is by large the biggest package manager. There's currently already more than 1.4 million packages there. So it's really huge packaging ecosystems. Here you see that what is the major source of information we used. There is, for those who don't know, libraries.io, which is a monitoring service that actually gathers the package metadata for about 37 different package managers, including the packages, their different releases, the dependencies between these packages, the dependency constraints, and so on. So this is one of the data sources we used for our analysis. The topic of my talk is about fragility of ecosystems. So there is many different reasons why packaging ecosystems can be considered as being fragile. For example, on one of the later slides, I will show that all of these ecosystems, they have seen a very rapid evolution and growth over time. Packages in these ecosystems, they can have bugs, they can have security vulnerabilities, they can lead to backward incompatibilities, and as a result, breaking changes in dependent packages. Packages can become abandoned or unmaintained because their maintainers do no longer contribute to it. Packages can get deprecated, which might mean a problem with dependent packages that want to depend on it. There might be incompatible licenses, which might be problematic. The way in which the policy is used for releasing and updating newer versions of packages might not always be the best one. And like this, there is lots of other issues that lead to the fragility of packaging ecosystems. All of this is, I don't know how to say this, exacerbated by problem. All of these packages are, of course, linked to each other by means of lots of dependencies. So this is commonly known as a so-called dependency hell. So what we observed was in all of these package managers, packages can have lots of direct dependencies and even many, many more transitive dependencies, which makes it very difficult to maintain and to manage from the point of view of individual package maintainers, but also from the point of view of the ecosystem as a whole. Because of this, you can have lots of broken dependencies, you can have co-instability problems, and so on. We try to somehow, the goal is to try to somehow measure and assess this. To do so, one of the things we have done recently, this was the topic of Ahmed Zerouali's PhD thesis last year about technical lag. Before providing concrete empirical results, let me just start with a simple case study, a simple example of things that could go wrong. So I don't know if you know about this. In NPM, I just was looking at what are the most popular packages. One of them that has been very popular over time is the request package. It's a very simple HTTP client. And it has already been around for quite a while. So actually, I was trying to trace what is the history, the evolution of this particular package. There is a neat tool that you can find here, npm.anvaca.com. It provides a kind of visualization of packages available in NPM. I'm not going to run the tool directly here. I didn't develop it myself either. But like if you see here, one of the earlier versions of request, version 2.10, it was basically just one package without any dependencies to other packages. So it started as a really very simple HTTP client that didn't depend on anything else. So at that time, it was really very reliable to decide, okay, if I need to use an HTTP client in my own package, I will just depend on request. Now, what happens in the future, the next version, there's already 2 direct dependencies, 5 indirect dependencies. So it's already becoming slightly more complex. Next version, well, it's not the next version, but this is version 2.16. There's already like 10 to 12 different direct dependencies. So suddenly, for some reason, the number of direct dependencies has exploded. It has become more complex. It's direct dependencies, so it's still relatively easy to manage because you can see your direct dependencies. It's much more difficult to see what are your indirect dependencies. Request 2.18, which is the first version that's actually available on GitHub. There you can see that the problem became even worse with many more transitive dependencies. And actually, so this is the case version 2.88. This is one of the really latest versions in 2018. Here you can really see there's a huge number of direct and indirect dependencies. So they really started to get some maintainability problems because of the number of direct and indirect transitive dependent packages. On top of this, actually, if you look at GitHub or even on npm.js, basically this, The very latest version of this package, version 2.88.2, which is very close to this one because this is just 0. There's just 2 extra patches that have been made, has been deprecated by its author. So the package is no longer available. But still, if you see in this version, there is 5 million different GitHub repositories depending on the package. More than 50,000 packages in NPM are depending on this package. So actually, here you can see a small message from the person that actually developed this package. And he says that if you basically, he stopped maintaining this package, and he actually suggests all the persons depending on it to move to something else. So it's no longer a good idea to continue depending on request. This was 3 months ago, but even today, if you would look at this package, there is still a really huge number of dependents to this package. So now the question is still, let's say that I do no longer want to depend on this package. What should I do? Here I just provide you some alternatives. I was looking at what are the different other kinds of HTTP clients available on NPM. There is some smaller ones like TinyJSON or Needle or Axios or NodeFetch. In terms of their package dependency graph, they are quite okay to deal with, very small. But I wouldn't be able to say immediately which one is the best. They all look okay, but you should actually dive into the details about the quality of these packages to be able to know what's the best one. There's also some bigger ones, but already have quite a complex dependency graph. So they offer more functionality, but I don't know if it's a good idea to depend on them because they are suffering from the same kind of problem that request is suffering from. So this actually leads to lots of research questions, of which I will tackle some in my presentation. By the way, this may be for the host, Eleni. Whenever I'm running out of time, maybe 5 minutes before, you can just open your mic and tell me, because I don't see anything else here than my current screen.
Okay.
Yeah. So basically, the research questions, we can provide them from 3 different points of view. The persons that are maintaining a particular package that is depending on another package. In that case, if you depend on others, you would like to know, when should I upgrade the version of a package I'm depending on? Should I always stick to the current version, or should I try to always take the most up-to-date versions of my dependencies? There should be a kind of balance. How should I manage the explosive growth of dependencies? So you should try to limit the number of direct dependencies you have, but it's much more difficult to limit the number of indirect dependencies because you don't have any control over this. How can you avoid depending on fragile packages? Maybe you depend on some package that for some reason gets fragile, it gets bugs, it gets vulnerability issues, its package is no longer maintained. How should you deal with it? How should you even know about it? How should you deal with breaking changes if for some reason a package you depend on is providing a breaking change in your own package? And if you decide to go away from this package and you want to look for an alternative, which alternative should you choose if there is multiple ones, and how should you migrate to these alternatives? Each of these bullets, is probably can lead to many different research papers by itself. Some of them have led to many research papers. From the point of view of maintainers of required packages, so you have a required package, which is a package that is being depended upon by others. There you would like to know, if I'm maintaining a package, how can I assess the impact on all of the packages that are depending on me, directly or transitively? Can I measure, for example, how much of my entire ecosystem is actually depending on me? Also, if there is bugs and security vulnerabilities in the package I'm maintaining, how can I make sure that if there is a fix or a security vulnerability fix or a bug fix of my package, how can I inform my dependents of this? And how can I make them adapt these fixes as fast as possible? How can I avoid having breaking changes in packages that depend on me? What should I do if I decide to deprecate a package? Should I give some time for the dependents to find some solutions? Should I help them finding solutions? How could I avoid having my package becoming unmaintained? Should I find replacements, other contributors that should take over, and so on? And then from the point of view of the ecosystem, how can we find an ecosystem-wide view of all of these problems? which are those packages that have the most impact, how fast is the ecosystem declining in terms of quality, how do different ecosystems compare in terms of fragility or healthiness, and so on. So this is basically the range of research questions that we have been and are currently studying in our research. Here, just for the first question, which is how fast are our ecosystems growing? Basically, here you can see a small table where I have looked at the growth in terms of number of dependent packages and number of dependencies over the last 2 years for 4 major packaging ecosystems: NPM, Ruby Gems, Packagist, and Cargo. And basically, if you take the percentage of growth over the last 2 years, so it's not annual growth, but it's biannual growth, you can see that's really a huge, an immense growth. So 93% more packages in NPM in 2 years' time, 156% more of dependencies, and the numbers are also quite high for the others. For Ruby Gems, it's slightly lower, but still you can see an extremely fast growth. In fact, if you look at a paper that we published in 2019, where we actually compared 7 different package managers, we experienced the same amount of growth. Basically, we looked at the rate of growth in terms of packages and dependencies in these 7 different ecosystems. And what we found was actually an exponential growth in these packages. I'm not showing all the figures here, just one figure that shows a dependency growth, which is exponential. It doesn't maybe look exponential on the figure, but that's because we have a log scale on the y-axis. So most of these ecosystems are actually growing exponentially in time. The biggest growth is NPM, as we have seen before. That's the purple one. And another one that's also a very quick grower, it's the youngest one, Cargo. It was only created somewhere in 2014. It's growing much more rapidly. Here, the figure is until 2017, but we can actually see if we would do this again in 2020, it has already surpassed C-run by an order of magnitude. So it's becoming like a bad student because it's not behaving as it should be in terms of quality and fragility. Okay. Another thing we found was, if you look at the dependency networks in all these package managers, they're actually very highly connected. Basically, you can take a node in this package, like that has some dependencies. And if you take this node and you move it around, you will take with you 60 to 80% of all of the other packages. So they all form one single cluster in your network. Another thing we found was in terms of dependencies, basically, there is like about 20% of all the packages that seem to collect all of the, about 80% of the incoming dependencies. So some packages are dependent upon much more frequently than others. But this is a typical example of the power law that you can find in lots of other empirical research about software evolution. I'm not going to show this slide. So a well-known problem that we can find, and there is like horror stories about this on the internet, is that sometimes a single package can cause really a lot of problem in many other packages. The most well-known example was leftpad in NPM. At some point, the maintainer of this package decided to remove leftpad from NPM, and because of this, in just in 1 second, like 2% or more than 2% of all of the packages at that time available in NPM became uninstallable. This was an impact of 5,400 packages. In Ruby Gems, there was some similar thing that happened. There was one package that had a broken dependency, and because of this, another package, which was usually popular, caused 5% of all the packages in Ruby Gems to have problems, to break. So this is an interesting finding where we wanted to have some evidence. Basically here we have a measure. So can we actually measure what is the transitive impact that some packages can have? So basically we use the metric, which is the impact factor for dependent packages. And basically it can be, it can be parameterized with a factor, in this case is 5%, where we say, okay, of all the packages in the ecosystem, if this package would have a problem, how many other packages that are transitively dependent on it would potentially be impacted? And there we showed the evolution over time. Again, you can see the purple curve is NPM. It grows over time quite a lot. So there is more and more packages that are having a higher and higher impact in the ecosystem. There is a small decrease here somewhere around 2016. surprise, surprise, why is this the case? Basically, this was the left path incident. So basically there, the community has learned from its mistakes and it went down. It didn't go down a lot because it still stayed quite high. I don't know what happened today, 3 years later. Is it still remaining stable or is it going up again? The other bad learner, Cargo, you can see it started very low, but it's becoming the second highest in terms of packages that have a potentially large transitive impact. Okay, why is this the case that these packages have such a high impact? Basically, it's related to the structure, the topology of the package dependency network. Basically, in Cargo, here, this is the red one, and NPM, what we show here is the number of packages, the proportion of packages that have one dependency, direct, two, that's indirect dependencies, level 3, dependencies of dependencies of dependencies. So here you can see how deep in the dependency graph you have to go to find all of your transitive dependencies. So in a normal ecosystem like CRUN, most of the dependencies are direct or level 2 or 3, but in ecosystems like Cargo, level 6 or higher, there is more than 50% of all the dependencies. And for NPM, that's more than 35% of all the dependencies have a depth of 6 or higher. So this is basically the reason why these two ecosystems are more problematic than others, because of their too deep dependency graph. So that's something that I think the community should work on. So the other thing I mentioned was technical lag. Basically, when and how should you decide as a package maintainer when you depend on other versions to upgrade your versions? On the one hand, the positive thing of having up-to-date versions of your dependencies is you can benefit from the latest bug fixes, you can benefit from security fixes. You will always have access to the newest features offered by the latest versions of these packages. On the other hand, it can take quite some effort to be able to do the upgrade. And if you do the upgrade, you might risk having breaking changes because of doing it, especially if your dependency has done a major version update. So there is good points and bad points. So somewhere you should try to strike a good balance between both. To do so, what we have done recently, well, as I mentioned before, Ahmed Zero Ali's PhD thesis, we developed based on the ideas initially proposed by Jesus Gonzalez Barahona, the notion of technical lag. Basically, we tried to provide metrics that measure to which extent a package is updated with respect to the more ideal situation. What ideal means can be parameterized into this metric framework. Ideal means perhaps the most recent package. So you want to depend on the most recent version of some package, or you want to depend on the most secure version of a package, the one that has the least bugs, the one that's the most stable, whatever you can come up with and that you can actually quantify, you could use this as a measure. I will not show you the definitions of the technical lag framework. To do this, just have a look at that paper because I don't have time here. But I will just try to show this intuitively. So suppose I have a package that is depending on many other packages, of which this one. Currently, I'm depending on version 1.1.0. If this is the case, then I can see that if I would like to depend on the latest one, which is 2.01, I'm clearly out of date. And I can measure the time lag. So how much time am I out of date by computing the time when this version was released and the time when this version was released. And the difference in time is what we call the time lag. You could measure the same in terms of version, rather than looking at how much in time you are out of date, you can measure how much versions am I behind. In this case, I've slightly changed the numbering scheme because in practice, sometimes it can be that some version number 1.2.0 is after a more recent version number if two different major versions are being developed in parallel. So in this case, it's clearly, if you want to say, I want to always have the most latest version, you don't want to go to the one that has the highest time, the highest time lag, 1.2.0, but the one that has the highest version. So in that case, you would like to update to this version. In that case, here we can say that, okay, there is one major version because the major version number 1 goes to 2, and there is one patch of this major version. So you are behind with one major version and one patch version. So this would be the version lag. There is different ways in which you can define version lag if you want, but let's not go into this right now. Vulnerability lag. Yeah, 5 minutes. Okay. So vulnerability, like the same. Maybe you want to upgrade to the package that has the least vulnerabilities. So in this case, it's version 1.2. Bug lag, the one that has the least bugs. In this case, it's more challenging. Which one should you choose? Stick to the one that already has a bug. If you would upgrade, it has more bugs. Maybe you should downgrade to another one because it's more stable, it has less bugs. In that case, downgrading could be good in terms of bugs, but maybe downgrading has other disadvantages. And interestingly, a recent study by Hassan et al. Have looked at downgrades in the NPM ecosystem. So this is a little bit related to this, but also it didn't really use the technical lag framework. Okay, since I only have 5 minutes, I don't think I will be able to spend my time on everything here. Okay, so let me see what I will talk about. Okay, so I will just continue with the technical lag, and well, the other parts of my slides, they are available anyway, and you can find them on the internet. I have shared them through SlideShare, and I can always offline talk to you about it. So one of the reasons why there is technical lag in these ecosystems has to do with how dependency constraints are being specified. So here, for example, I don't know if you know about semantic versioning. Basically, if you want to avoid breaking changes, you can allow minor versions because they are supposed to be backward compatible. You can allow for bug fixes, but if you also upgrade to major versions, you don't have any guarantee because they might introduce breaking changes. So in most of these ecosystems, using the carrot constraint for your dependencies will allow you to accept all backward compatible changes, but not accept breaking changes. So we studied this in NPM, and basically what we found that to which extent are dependency constraints being used in NPM? And surprisingly, what we can see in this slide, the purple curve shows that like about 30% of all the dependencies, they are using strict constraints. Strict constraints means they don't allow any updates at all. So they could actually, this constraint could be flexed to become more semantic versioning compliant. And we actually did some kind of what if analysis. Basically, if you would do this, you would be able to reduce your technical lag by a factor of 17% to allow those strict constraints to be replaced by constraints that allow minor versions and patches only. So unfortunately, I'm running out of time, so I will stop here and maybe directly go to the conclusions. The reason why I have so many slides is because initially I thought I had 45 minutes instead of 30. So we have seen that packaging ecosystems are affected by lots of fragile dependency issues, mostly due to many deep transitive dependencies and the fast growth of these ecosystems. And it can lead to problems if your dependencies become deprecated, have breaking changes, or unmaintained packages. What can we do from a tool and policy point of view? Basically, if you should actually try, whenever you're a package maintainer, continuously use monitoring tools for detecting dependency updates, but also for security vulnerabilities. You should try to support and adhere to semantic versioning as much as possible. And one of the main problems we found in the existing tools is that they do not really support transitive dependencies. From the package developer point of view, it's really very difficult to find out what's happening in transitive dependencies that you depend upon. And also for the maintainers, it's very difficult to know which other persons transitively depend on you. Another thing where there's little support is how can we actually try to find migration scenarios to alternative packages to help us whenever we run into trouble. Okay, with this, I conclude my slides. As always, I speak too fast and I have too many slides, so I hope this was not too much a problem. Thank you.
Thank you very much, Tom. So we have some questions on Discord. Walter asks that he may have missed this, but are package managers interested in incorporating these metrics in library pages or adding them as filters on their website? Did you actually contact package manager maintainers and see, or ecosystem managers to see what's the interest in those metrics?
Not really, but well, actually, yeah. So there is two things. We have been involved in the Chaos community, which is, so the Linux Foundation has the Chaos community, which is a a shortcut for community health analysis of open source software systems. In this community, there's actually metrics being developed for these types of problems and others. And we are actually actively involved in these communities to try to look at how can we improve these metrics and make them more widely usable. What we didn't really directly do is to try to just like sell these metrics to specific communities, because our view is basically to try to have like a more ecosystem agnostic approach. And also, I think we first need to have more evaluation and be sure that these metrics are really useful in practice on many different ecosystems, and trying to like having tools that support them for one specific ecosystem will be a lot of work. But what we would like to have is tools that are as ecosystem agnostic as possible. So, but through this means of this chaos community, because they're also providing tools, and some of them are, for example, being integrated in like the Grimoire Lab software analytics tools that is developed by the Bitagia company. We try to have like generic tools that can help and be used by other ecosystems.
And Miroslav is wondering, so let's say that actually you're a maintainer and the new version may have a completely new interface that you're not interested in, or it can also have a vulnerabilities and interfaces that you're not actually using. Yeah. So how do we take this into account in all this analysis?
Yeah, but then, okay. So that's indeed, this means, this may be something I forgot to mention in the beginning. So something where our current research differs from like the one done in the FASTEN project is, for the moment, we are just adopting a coarse-grained approach. So we are not looking at anything at what happens inside the package. And so I think it's quite complementary to research where you're actually looking at how are your packages actually being used internally. I think it's another topic, but it's definitely, it should be combined with this topic, because like I know other researchers that are working on this, and for example, you want to know, okay, if I see that, so you can again do some kind of like crowdsourcing analysis. I have a package that I'm developing. I know that many of my like many other persons are using my package. If I see that 50% of those persons are only using like 50% of the functionality of my package, it's always the same functionality. Maybe I should split up my package into like 2 sub packages to reduce the weight in some sense of my package, and reduce also the likelihood of having potential problems. But to be able to do this, we will effectively have to look at how are the methods within my package being used by my clients. We didn't really go into this. It was not our purpose. And I know that other persons are doing this, including the FASTEN project, but also the guys that are in, where is it? In Norway. The team of Benoit Baudry and his colleagues are also studying this.
Okay. And then Andre asked that probably bots like semantic release will assist developers with keeping their releases to adhere to semantic versioning and allowing less strict dependency constraints. So would it be interesting to assess the impact of such tools in the near future?
About which tools?
There are bots like the one called semantic release that will assist you to keep your releases adhering to semantic versioning.
Yeah, indeed. I think that would be very interesting. So one of the questions we asked ourselves is, how can you actually, the problem is that semantic versioning is not really, it's a policy. So it's not possible to actually force someone to use it. But the question is basically currently, if you don't have a bot like this, it's even sometimes people don't even know that they are not adhering to it. Some people actually consistently don't want to adhere to it, which is another thing. But I imagine that if you have an automated bot or other tools that show you consistently that well, either you're not respecting it and you should respect it, or they show that there is problems with not respecting it. Having such automated tools is definitely, yeah, it should be also in my bullet list on the current slide, because it could definitely help. I think in a more general sense, one of our others, that's another research work that is probably interesting to research, is not only that particular bot, but in general, to which extent do automated bots help you in supporting and increasing the fragility of your ecosystem. I think for most of the other points I discussed today, some kind of support through bots could also be helpful in this sense. There's lots of other types of bots that help you in different types of processes, but actually studying how these bots help, this has not been done yet. I think maybe it has by others. Of course, what you will need is enough data to for how these bots behave to be able to do decent empirical studies. So I don't know if there is still already enough data available. Maybe this, maybe it isn't.
Okay, and then Damian asks, so how in the end, how do we select the ideal version of the package that we're using? There might be unknown bugs, unknown security vulnerabilities, and in the end, how does a developer decide which is the ideal version to depend on?
Yeah, I don't know. I think it's a context dependent. So we did some, Ahmed in his PhD study did some survey with the developers about this, about what is the most optimal version to depend upon. And actually the responses he got were quite varied. It actually depends on the context. It depends on the developer. It depends on the project he's working on. It even depends on sometimes the same developer on different projects would make a different choice. So one developer told that, okay, he was working on like some kind of research project, and in that case, he doesn't mind if something breaks from time to time. In that case, he always wanted to depend on the latest version of some package. And then he was also working on some commercial project, and there he always wanted to have the most stable version that didn't have any known security and bug vulnerabilities. So it's not something, that's why we defined a technical like framework. It's not something that is up to us to decide. What we need is like a generic metrics tool where you can, as a developer, decide what is the goal that you have in mind, what is the type of, what is the best thing to choose depending on your particular context, and based on this, apply your metrics and see what is the most optimal package to depend on.
Okay, and Hagen asks, does awareness of this issue differ between communities, for example, like Rust versus JavaScript versus Python? And if I understood correctly, Hagen, please feel free to unmute your mic. By this, you mean about the ideal versions to select?
I think it's in general, probably.
And he also asks, if so, what are the more responsible communities doing differently?
Yeah, I think it also depends. But what you can see is like some communities, they are attracting a lot of persons with that are much less experienced in programming. So I'm not going to. Oh, okay. I'm not going to tell any names of particular ecosystems here, since we are on also on YouTube. But what we did, we didn't do an analysis because it's quite difficult to actually assess this and be fully correct. But depending on whether your community attracts more like newcomers, so persons with less experience in programming, and I think this is clearly programming language dependent, you will see that these communities have more problems than others. Some other communities, or programming languages, they really are proud of their language and they want to do everything as a high quality level as possible. So you can actually really see, because of this, a difference between these different communities and their ecosystems and their languages. And this indeed does have an effect on some of the metrics we have found. But how to like formally show this is much more difficult to do. For this, we would actually have to dig into who are the real developers in these languages, what are their experience, and things like this. But I think the answer is yes, but well, we don't really have like full quantitative support for this.
Okay, I see people typing on Discord, and until they do type their questions, I'll ask one of my own. So you've mentioned fragility, and fragility can be due to transitive dependencies towards your own package. Basically, you don't have control over who depends on you. However, somehow you contribute to the fragility of the ecosystem, right?
Yeah. Yeah.
So in the end, how can we solve this? I mean, who will carry the responsibility? What do you think can be done to try to mitigate this situation, not have too fragile ecosystems?
Sure. That's actually what I showed in my slides, and go back. That's why we have these three different points of view. Let's go back a little bit more. So the problem is from the maintainers of required packages. This is the problem. What we need is this third point of view is we need some kind of official role by ecosystem managers. So persons that are responsible for looking at the ecosystem as a whole. It could be a single person. It could also be like a group of persons that is like a foundation that is looking at the ecosystem and looking at its fragility problems. And based on this, make specific decisions or like looking at identifying, okay, right now I see this particular package that is increasing its fragility. So maybe we should contact this maintainer for doing something about it. Maybe we should take actions ourselves. Maybe we see that some of the slides I didn't show was semantic versioning policy. Sometimes we see, okay, semantic versioning is not really being used in the ecosystem. How can we improve upon it? So it could be an actual conscious decision by the ecosystem. I just wanted to show the slides to see that sometimes this can make a difference. Here, for example, what we see in this picture is the adherence to semantic versioning in 4 different ecosystems. And we can see actually the blue curve is showing ecosystems that are becoming more and more semantic versioning compliant over time. All of the 4 ecosystems studied here, they are becoming more compliant over time. Cargo is actually basically almost 100% compliant right now, and PM is really highly compliant, but still there is some kind of too restrictive. This is a 33% I mentioned before, and then some others are really worse. But sometimes there is like specific actions that happened. I don't know anymore for Cargo what was it, but here suddenly from one point to the other, something dramatically changed in the positive sense. So probably there was some kind of ecosystem-wide decision that has been made to do it. Here you can see this. I think this was the, if I remember well, for NPM, this was the switch where they changed the way to interpret the tilde and the caret dependency constraint in the good sense. And because of this, suddenly the compliancy with semantic versioning went up from basically 0 to like 80%. So the ecosystem policies can actually make a difference for some types of things you want to improve. And the ecosystem measures should also continuously look at what are the problematic packages, like the problem I mentioned about the request package and the deprecated packages. I don't know if the ecosystem managers are currently doing something about it, but trying to help all of the persons that are currently depending on request, trying to help them migrate to others would be a good solution for that specific problem.
We'll continue this discussion during the break because there's also always a balance, right? Because some communities that impose too many policies put the burden a lot on the developers, so that's why they're smaller. So, but we'll continue this offline during the break. And I would like to ask one final question asked by Petar, if I am saying the name correctly, I hope. So he's asking actually, he's very curious that if there's community maturity research specifically for packages and dependencies. So if I understand this correctly, basically how mature the research is specifically for packages or dependencies. Petar, can you please unmute your mic? Or if there is,
is it about maturity of research or maturity of the community?
Yeah, if there's community maturity research specifically for packages, dependencies, and community maturity is in quotes. So I would presume that community maturity of the ecosystems.
I would assume it's the ecosystem. I don't know. Maybe
you can answer both. I would say let's say go with ecosystems because it makes more sense, and I don't see. I cannot see if Petar is here to unmute.
Yeah, I would say for research, research is never mature. You always have to find out. There's always more things to do. There is not like a consistent set of metrics that currently exist for measuring these things, so it's still in its infancy. For community maturity, I also think it's only recently that because the growth that we've seen in all these ecosystems, like if you take for example Cargo, it only exists since 5 years ago. So basically starting from 2016 only, that's 4 years that this ecosystem has been growing. So obviously, for some good points, it has been able to learn from the others. For others, it was worse. What I have seen lately, like very recently, since beginning of this year or something like this, is that all of these communities of package people that are developing package managers, they have started to discuss with each other about the good things and the bad things in their different package managers. There was even at FOSDEM, there was also a specific meeting for that. And basically they are trying to share their good stories and bad stories and try to, I think, come to like common tools or standards that help as much as possible each other in trying to improve maturity. Whether there is some like a standard about what is the maturity of a particular ecosystem, I don't think it ever exists, and I don't think it will ever exist because there is still and there will always be too much variation between the different ecosystems that makes it impossible to achieve such a thing.
Okay, thanks, Tom. Actually, Peter responded on Discord that, yeah, you got it. It's you answered this question. I see more questions. Unfortunately, I will have to stop the session here because we're already a bit over time. So, Tom, thank you very, very much for the very, very interesting keynote. Let's continue the discussion on Discord and let's be back in 9 minutes. Sorry, I took quite some time off our break. So let's go for a quick break and be back in 9 minutes to continue with the next session. See you at Discord. Thank you, Tom.
You're welcome.
Welcome back, everybody. I'm sorry I interrupted the very interesting discussion on Discord. We will continue it later for sure.
So, so much like a real setting, right? So now we go back into the main session in the room.
Yeah.
We can take over during breaks the hallway discussions. So
yeah, instead of nudging people all the time, saying "come on, come on," you just mention it on Discord. Okay, so I'm gonna give the floor to Felipe, who is the session chair. Felipe.
Hello, good afternoon, good morning. Can you hear me? Okay, good. Good to see you all still around. Welcome to the last session. My name is Felipe. I'm a postdoc researcher from the Eindhoven University of Technology. I'm mostly interested in working in both technical and also social aspects of the software revolution, specifically in code reviews. And I'll be the chair for this last session, which is about evolution theory and practice. So let's start with the work of Alex. He's from the University of São Paulo, from Brazil as well. I'm from Brazil. So Alex, the stage is yours.
Thanks, Felipe. Can you hear me well? All right, so I'll try to share my screen here. Let's see if it works. Okay, I think it's working.
Yes.
All right. So my name is Alex, and today I will be speaking about OASDB, which is our work in progress research. It's a repository of specifications to support OpenAPI research. Okay, so we have a popular architecture style for building web apps and web APIs, which is REST, representational state transfer. And we have different kinds of specifications for describing APIs. The most popular one is OpenAPI, which was formerly known as Swagger. And in the last years, we have seen in the community research some works that try to verify characteristics of REST web APIs automatically, generally using a specification such as OpenAPI. For example, to try to detect REST anti-patterns in a given web API. The problem, however, is that there is not a standard OpenAPI repository. And this is an issue because it means researchers have to spend time building their own data sets. And it also makes it much harder to compare different studies. So our proposal is to create a repository that maybe can become a kind of a standard, which is OASDB. And OASDB will be a collection of synthetic, but realistic annotated OpenAPI samples with known issues. And by issue here, I mean REST anti-patterns. OASDB will not only be a repository, but actually more like a toolkit. It will also include a CLI to allow the generation of mock servers from the OpenAPI samples. I'll be speaking a little bit more about that towards the end of the presentation. Okay, so if we think in a common interaction in for example, REST API, we could have something like is shown here in this slide. So maybe we have an e-commerce application, which is an API, and we also have the mobile app. The mobile app makes requests, HTTP requests to the e-commerce application. So for example, let's say we have an endpoint that allows the mobile app to retrieve information about a specific customer. So we could have, for example, an endpoint that expects some kind of customer ID. We would use, for example, the get HTTP verb, and we would receive as a response from the server something like a JSON JavaScript object notation payload with the name of the customer. And if we think about this same example, this same endpoint in this fiction, imaginary API, here's how we could describe it in OpenAPI. So we could say, okay, we have this endpoint which expects a customer token. It uses the get ATP verb, and it expects some specific parameters. So in this case, the customer token. This is an example of an OpenAPI sample. And as you can see, OpenAPI is a very rich specification. It allows you to describe a lot of characteristics of the API and its endpoints and operations. When we think about related works, we do have some API collections that appear in some of the works in the field. Two examples are APIs Guru and Rapid API. APIs Guru is a collection of OpenAPI samples, and Rapid API is a collection of APIs in general. Not every entry in Rapid API has an OpenAPI sample available. However, there are two major issues when one tries to use these existing collections for research. The first one is that there are no annotated samples. So, okay, you do have the OpenAPI sample, but you are not sure if there are, for example, REST anti-patterns present there. So if you are trying, for example, to build a tool to detect REST anti-patterns, basically you have to then manually check, for example, for trying to see if you do have true positives, you're going to have to check manually the samples to see if the anti-patterns that you detected are actually there. And of course, this is very labor intensive. Another issue is that these repositories, they are not built with the purpose of having a diverse set. And by diverse set here, I mean both in terms of the anti-patterns that appear in the collection as a whole, and also in terms of the system domains that are represented in the different OpenAPI samples that you have in these collections. And OSDB does not have these issues. Okay, so we set out to build a proof of concept of OASDB. What we wanted to do with this proof of concept was basically to specify the structure of the annotation files, which I will show in a moment, and also to brainstorm the overall architecture of the repository. And the proof of concept, which is very small, there's only a few samples, is present in this URL here in this slide. The samples that we are creating and adding, and will be adding to OSDB, they are created manually, and they are based on 3 pillars. So we are looking for cataloged REST anti-patterns that are present in the literature, and creating samples that have these anti-patterns with the purpose of having a very diverse collection. Also, we are looking for papers that show anti-patterns and bugs that found in real-world APIs. And parts of our research is also to try to catalog new REST anti-patterns. So we will also include original ideas of our team, when we can, of course, support these ideas with the literature or with something reliable in the software community. So, for example, if it's a security issue, we will try to support our idea with CVEs, for example, by citing CVEs. So talking a little bit more about the generation of mock servers. We are leveraging this open source tool, which is called Prism. And it's very important to have responding servers because if you're trying, for example, to detect REST anti-patterns, some anti-patterns can only be detected by interacting with a responding server. You cannot detect some anti-patterns only with static analysis, only by looking, for example, at an OpenAPI sample. You have to interact with the responding server. The idea is that you can run these mock servers locally on your machine, or you can deploy them to a cloud environment. Part of our work is to specify an adapter interface. So by following the interface, it will be easier to support different cloud environments. Out of the box, OASDB will support Amazon Web Services, but as long as one respects the interface that we are going to define, it should be possible to add other cloud environments. So here's an image that shows the overall architecture of OASDB. We have the samples. Each sample has an annotation file. We have the tool for generating the responding servers from the samples. And here's an example that shows on the left an OpenAPI sample, and on the right, the annotation file that I spoke about during the presentation. So in this annotation file, we have all the violations that are present in a given OpenAPI sample. So for example, let's say we have an issue that we are calling the path. We have the categories that this issue can be classified. So understandability, security, we have the specific offender, the location of the issue, the REST anti-pattern in the OpenAPI sample. And to finish the presentation, our future work is, of course, to turn OASDB into a real repository with dozens of samples. So we want to cover more types of anti-patterns, more system domains. And also now we are working in actually implementing the mock server generation feature that I spoke about. All right, thank you very much. Now I will be taking questions if there are any.
Thank you, Alex. Nice talk, by the way. I really like it.
Thank you, Felipe.
So are there any questions? I don't see, well, there is some come on the Discord app. I have some. I was wondering about the API evolution. How do you plan to deal with that, or if you plan to deal anyhow?
You mean the evolution of the repository itself?
Both.
So,
I mean, the API, they got new versions, they fixed some issues and they improved. And how do you plan to deal with that? And also how that would reflect in the repository?
Okay. So talking about the evolution of the repository, it will be open source. So our idea is to have like a guideline to help other developers and researchers that want to contribute and, for example, add more samples. And by the evolution of the API, you mean the API of the mock server generation tool? I'm not sure I got that second part of the question.
I mean,
because we do have the samples, and the idea is that, so for example, maybe you are developing a tool to try to detect issues in APIs in general, and you need to know if your tool is actually capable of detecting different REST anti-patterns. The idea is that you can use our repository to help validate your research.
Right. So the repository is about the REST anti-patterns, right?
Yes.
Okay, good. Thanks. Any further questions? Just it seems that we don't have questions on Discord. Someone wants to ask questions here? Okay. We still have some time.
Yeah, if there's something that is not clear, or maybe I spoke too fast about some specific parts, just let me know and I can try to clarify the presentation.
Okay. So we don't have any questions. Thank you, Alex. I think we can move on to the next talk.
Thanks a lot, everyone, for the attention.
Oh, sorry. Anna?
Yeah, just I only had a quick one, since it seems to me that your work is connected also to reproducibility in some way. So correct me if I'm wrong. Maybe I didn't understand correctly. But then if that's
No, it is, yeah.
yeah, so then if that's the case, do you have already in mind some kind of ranking or some threshold, some model of reproducibility that we could assess papers such that we can give also an actionable list? So that someone, if I tell you that your paper is not reproducible enough yet, but then I can also tell you what you could do to make it so, to make it more reproducible.
We are not there yet, but we do plan to, after we have the repository with more specifications, we do plan to run some of the existing tools that researchers have created in the last years and try to see how we can not only validate our repository, but maybe have like a more defined framework to help researchers determine if their tool is mature enough, good enough. I'm not sure if I answered your question.
It's exactly, so we have a maintainability model, well, maybe multiple, but there is at least one maintainability model. So something like a reproducibility model would also be helpful, because usually these models are useful since they tell you what you can do to improve. So using that, you can know what actions to take to move forward with your, for instance, in this case, a repository. So that was my question, basically, if you had that in your future work, but it seems you do. So
Yeah.
Okay. So I think are there any questions? Okay. So let's move on. Thank you, Alex, again.
Thank you.
So let's move on to the next talk. The paper is going to be presented by Walter.
Yes,
I hope
I'm here.
Said it correctly.
Yes.
A master student from the University of Amsterdam.
Yeah.
And he's going to do a nice presentation about cyber physical systems.
Yes. Anna, could you make me co-host? Or Eleni? Yes, thank you. All right. Well, I will be presenting part of my master thesis work, which is about facilitating resilience in cyber physical systems using coordination languages. Well, that's a whole mouthful. Let's start dissecting that title. We'll first start with cyber physical systems, explaining what those are. Then we'll move on to coordination languages, and then we will end with resilience. So cyber physical systems are a very recent paradigm of embedded systems, but they are more distributed. They are about the interaction between our physical world and the world of computers. Examples are autonomous vehicles like cars, drones, but also smart city applications. But they have a much wider range of examples. These systems are usually distributed, often safety critical and real time. And they also have to deal with a couple of non-functional properties. So properties orthogonal to the working of the application, but still important. For example, for mobile applications, portable applications, energy is very important. Same as security or time. So these aspects add to the application complexity. And my research is about how do we manage these properties, specifically resilience, while not increasing complexity of applications. For this, we move on to coordination languages, which is a model or models for multiprocessing applications, which started in the 80s. They have evolved over time, and they now emphasize separation of concerns between a coordination layer, which sits on a high level, and a computation layer, which is more low level. Now, the computation layer is about the individual pieces of an application, and it's mostly about functional correctness. While the coordination layer is about gluing these activities together and defining how they interact with each other, and also managing dependencies between these different activities or components. At the UVA, we've created a DSL for the management of non-functional properties, especially energy, security, and time. So the idea is to manage these from the coordination layer. To do this, we have converted an application or represented an application with a directed acyclic graph in which each node becomes a component. These components are actually just normal 3D functions, but the way the components interact and how state is managed is done on the coordination level. So the idea is that we externalize state in tokens, which are produced by components when they fire. So here we have an example of a component, and these are connected to other components. So this is a very schematic overview of how the coordination language could look like. So by making this state explicit on the coordination level, it makes the components stateless. You're not allowed to keep state in the components in the C code. This makes things a lot easier in terms of predictability, but also structuring and also applying the non-functional properties. So let's go into a very small concrete example. So we have a subsystem of a car, which captures data from sensors, which first of all, an image and a distance. These are then put into another component called the decision component. You see these blue components, you do not have inputs. They capture data directly from the physical world. That's why they are called source components. The data from the source components goes into a decision or a set of components which do something with that data. For now, we've just chosen to represent it with a single component. And after that, an action comes rolling out. Here is a voltage for an actuator, which will then react or activate something in the physical world again. So this kind of feedback loop between finding something in the physical world, then doing some computation, and then reacting upon it. And these inputs and outputs correspond to the C function interface. So you kind of specify this interface on the coordination level, and it then dribbles down to the computation layer. So our work specifically focuses on fault tolerance or resilience, because the interaction with the physical world is often is potentially dangerous. If something goes wrong, something crashes, you can cause potential problems, even lives can be at stake. So how do you deal with hardware faults, crashing, transient faults in which the value of a component or a function is wrong, or messages that are not being delivered? And how do we deal with these errors or faults without intertwining these fault tolerance methods into the application code, which is done often in reality right now? So that's why we are also interested in utilizing this on a coordination level. So the idea is to specify the fault tolerance methods on the components themselves. So now we'll be talking about a few fault tolerance methods. I will not go into very much detail because I don't have that much time. But let's start with a simple one. A checkpoint restart is a method in which you periodically create a checkpoint and you restart when a checkpoint or a fault is detected. This sounds easy, right? Well, for distributed components, this can cause a domino effect in which the checkpoints become unstable because each has its own checkpointing mechanism. But we can mitigate this by the token-based approach, because the token-based approach makes sure that the entire state of the application is in the tokens. So you cannot have an unstable state. So that is why it's a lot easier to do in this coordination approach. So another method is primary backup or standby methods, in which you have two types of components: an active component, of which the output is used, and standby components that can be one or multiple. When an error occurs, the handling or the output is directed to a standby component, and that becomes the new active component. Another method is n-modular redundancy, in which you run n identical processes followed by voting processes, which vote on the right answer. So, for example, if component 1 has a transient fault in which the output of the function is incorrect, the fault is hidden away by the voting with the other components, assuming they are correct. And we can also deal with crash faults by applying a timeout on these in this method. And when in a real-time system, this is even more easy because you know the worst-case execution time. And you can, based on that, you can make a very nice estimate on when you should apply this timeout. Then a variation on n-modular redundancy is n-version programming. Here, we don't run the same process n times, we run a different process n times, conforming to the same specification, but it can be a different implementation. This allows us to tolerate software faults. However, creating this or making this work is very expensive because you need different implementations. This is partly mitigated by using the existing version mechanism of the language to avoid to kill two birds in one stone, because the existing version mechanics is used for heterogeneity. So let's say you want to run your component on a GPU or an FPGA or CPU. These are different architectures, and then we have different versions for these architectures. So then you kind of kill two birds with one stone, and this becomes much cheaper. So I see I'm going pretty fast, but here I'm going into my conclusion right now. Creating and maintaining cyber-physical systems is very complex due to the large amount of things you have to deal with, non-functional properties, real-time, stuff like that. That is why we introduced our coordination approach. But there's still a lot of work to be done related to software evolution. How do you maintain these coordination languages? How well does it what it was designed to do? Our contribution includes adding these fault tolerance methods to the coordination language and allowing the specification of these options. But we also looked into increasing programmability in the coordination language by structuring components into subgraphs. Then we can apply these fault tolerance methods on a higher level, so they don't have to be specified for each component individually. And we also removed the need for exact code duplication with templates. So you can instantiate an abstract definition of a component or subgraph to have basically duplicates without duplicating the actual definition. And here we also allow for templating. So if you want to know more about that, please read my paper. I did not have time to do that in my presentation. And then I want to finish with mentioning the EdMorph project, of which my thesis is part of, which is about actively morphing embedded systems and creating resilience through that. That was my presentation.
Thank you very much, Wouter. It was a nice talk. Are there any questions? It seems that you are a bit tired already. No questions on Discord. Okay, I was wondering, Wouter, by the way, really nice work. For me, it's quite interesting. Besides, I'm not very expert on this topic. Do you plan to evaluate this in a real application? Do you have plans for that?
Not specifically in my thesis, but it would definitely is on the roadmap, so to say, because the EdMorph project has just begun, and my thesis is more an exploratory work to find what are interesting approaches to facilitate this resilience in these kind of systems. And I definitely think at the end, real-time applications, or sorry, real applications will be a part of this. It's also necessary, of course, because you need to validate whether this works. So for my work specifically, I will focus on a simulation approach. But over time, this simulation approach will definitely be converted to the real world.
Okay, cool. Let me see here. Seeing that we are going to have one question. We still have a lot of time.
Maybe just I wanted to pick Walter's brain on when you say that there's still a lot of work to be done related to software evolution.
Yeah.
So which directions would you see in that part?
Well, first of all, so we have a DSL approach. Validating DSL is also always a lot of work to do, whether it actually does what it was designed to do, to lower complexity, and whether it's actually nice to work with. So these kind of things can also always be explored. Other things that can be done is finding other ways of exploiting this coordination structure in order to kind of make maintainability even more easy. So having more options on the coordination layer to manage your application and evolve it.
So do you already have a community in mind to target and victimize as DS?
I don't really. I'm not really planning to do it in my thesis per se. Sorry?
But in your PhD. Okay. So then that is really left for the next student to come along.
Yes, I think so. And it's probably also, I mean, this kind of research is very expensive. So if it's in a more mature stadium, it's often more worthwhile to do.
It seems that we have one question here. I hope I understand it correctly. Sab is asking if you could compare your DSL with the most well-known. Which one that would be? The competitor of your DSL.
I really wouldn't know. So I've looked into other things that do fault tolerance, but most of the things that do fault tolerance are actually not DSLs, but mostly are integrated in existing applications. So there is a trend to other things like to facilitate the resilience in more systematic ways, so that the programmer doesn't really have an influence on what kind of methods are being applied, but they're just applied system-wide. Theoretically, this is of course very inefficient, because you assume that's, or at least I assume in this domain, that some parts of an application are more critical and more important than others. So they require more methods, while other parts really don't. And then when you have these systematic approaches, especially if you have a battery that you need to also deal with, it becomes really expensive. So that's also a reason why we chose for this approach, is because it has a pretty fine or component-grained granularity, while other systems usually have system-wide granularity, which is very coarse. But there are a few frameworks that try to do it, but they often the structure is much less clear than in here, I think. But that's my personal opinion, of course.
Okay, good.
I hope that sort of answers the question, because I really don't know any examples.
Okay.
Yes, it's okay. Thank you.
We still have some time. Any other questions?
Is there anything on the YouTube, maybe?
Walter, I could not find the YouTube of today. Sorry for that. I was looking for the YouTube. I found the one from yesterday. If you send the link,
it's in general.
There are currently no questions on YouTube.
I see it.
Day one. Maybe that's also misleading, because it has a title day one on YouTube.
Yeah, then there are two.
Day two does not have any questions.
Okay.
Yeah, I think I broke it. I told them that there can be only intelligent questions.
Okay, so thank you, Walter, again.
Yes, thank you very much.
So let's move on to the next talk, the last for the day and also the conference. Quinten, I hope I said correctly. He's a master's student from the University of Amsterdam, and he's going to talk about causal inference on theory building in software evolution. The stage is all yours. Did you?
Okay.
Okay.
Can you hear me correctly?
Yes, yes, you can.
Good. Then let's get started. Okay, hi everyone. My name is Quinten Leidecker, and I'm currently doing my thesis on causal inference for theory building in software evolution. Cool. I want to start off with a little bit of background. In software engineering, but more specifically software evolution, there are currently no widely accepted general theories. Lehman's work on software evolution established several laws. These are somewhat general, though, and of course laws. Recently, there have been several calls to action towards a more theory-oriented approach in the field. You can see some references I put in the slides here. Yeah, they're showing, it's good. Note that there is an entire workshop that was dedicated to this whole process of theory construction. Some people say that a lack of theory poses issues for research in the field. Currently, there is a strong focus on exploratory research and finding interesting correlation in data. And this in itself is, of course, not a problem. But if we want to establish strong base truths, then this is somewhat of a problem. We actually want to have causality over correlation then. This also poses a problem if you want to aggregate knowledge. In these types of research, sample sizes are often fairly small, and experiments are done on select and narrow populations. Again, this is in itself not a problem, but this does influence representativeness. Conclusions drawn from these samples may be valid, but they may also only be valid on the sample that they are taken from. In general, theories, preferably, should not only hold in limited domains, but instead hold across populations. So our idea. Scientific theories have several requirements for validity. Among other things, they have to be empirical, well-confirmed, and falsifiable. Generally, we refer to theories as hypotheses when they are not yet confirmed, but still propose certain ideas. In this thesis, we refer to our ideas as propositions. There has been some work in our field on how theories can or should be constructed. Referring to work by Schoberg here, you can kind of view these propositions as level 1 theories, minor working relations that are concrete and based directly on observations. So in this research, we want to investigate a practical and visual way of exploring, expanding, and testing these propositions. We utilize a statistical technique called causal inference for that. Causal inference differs from statistical inference in that it tries to define causality. The causal relations under investigation can be visualized through diagrams. And a very important takeaway here is that causal inference needs more input than regular statistical inference. It needs a proposition to look at. This is all pretty abstract, so I want to give an example right away. This is the experiment that I am currently working on. In this proposition, we try to find the effect that an inconsistent change to a code clone group has on the cause that this change has to be applied to other instances of that clone class later. So we define a clone group here as all of the instances of a type 1 clone. The correction, which you can see in the blue in the bottom, we define as after having seen this inconsistent change to one of the clones, This change at a later point in time is also applied to other instances of this clone group. All right, so have a look at this diagram. We see that the event that a clone group changes, and we see the outcome, which I've named correction. This is just what I've named this later change to this clone group. There are two other variables in this diagram. On the left, we see test, and this refers to whether or not the clone group, so a clone group is a number of type 1 clones that are all the same. And test refers to whether or not this clone group has both test and regular classes in it, or it doesn't. On the right, we see number of instances, which simply counts the number of instances in this clone group. All right, so after this brief example, this visual example, I want to jump into causal inference. Let's take a closer look. So causal inference is used to determine the causal effect of an exposure. So we have a definition here. You can read it with me. A variable x, the exposure, is a cause of variable y, the outcome, if y in any way relies on x for its value. Okay, so how can we determine this causality? So what causal inference tries to do at its very core is to mimic a randomized trial using observational data. In a randomized trial, what you do is you compare two groups, one with the exposure and one without, essentially. So in order to guarantee that the comparison between these groups is valid, we have to ensure comparability. So one of the ways we do this is by controlling for confounding variables. In our previous example, the number of instances is one of the confounding variables that you saw. That means when comparing these two groups, so what you do is you have two groups and you start comparing individuals in those groups. And we only compare individuals who have the same value for the confounding variable. Another way to ensure comparability is to have a large population to select from, which is something I will get into a bit more later. All right, so theory building. So how does causal inference relate to theory building? We've established that there's a desire for this theory building. And the goal of this research is to investigate a very practical way of getting started with this. We want to see if there's any merit in using causal inference to establish these propositions. So this poses the question, essentially, what do we want to achieve with these theories and how does this approach achieve that? It's argued by some that instead of generalizing from small samples, instead we want to generalize across populations. Another goal of theories is to explain and predict. This is where causality comes in. And I briefly spoke about the complexity of theories. And again, the goal is to start very small here with these type 1 theories, propositions, actually. Keeping it practical is important here. And I'll go into that a bit more. So causal inference. Does causal inference achieve the things that we just set out? So with causal inference, we try to generalize across population. But for that, we need a large data set that allows us to do this. Currently, I've only tested on a very limited data set, but I'm in the process of collecting over 30 repositories to do this on. As we are looking at software evolution, we also need access to the commits. I use PyDriller for that, which is a Python framework. Now, these large amounts of data, I don't think that this should ever be a problem. It's really quite easy to query 3 million GitHub projects. So in our modern ecosystem with all these developments, this shouldn't be too much of a problem. So practical. The causal inference approach is practical. As we've just seen, the diagrams allow for an easy way to view what you're doing, but also share this with others. These diagrams allow for very quickly and easy insight into the proposition that you're describing or that you're looking at. And causal inference can help us in this way in building propositions. It's important to note here that the intention here is not for every proposition to be correct right away. Propositions are small and testable. And what we want to do is share those ideas. Maybe other researchers don't agree with the relations defined in the diagram. Maybe you don't agree with the diagram I showed. Maybe they don't agree with the confounders I've chosen. And that is the goal. Discussion about these things is the goal here. We want to facilitate these discussions through this causal diagram process, so that maybe we can establish some definite ground truths. Then I want to go into a little bit of discussion. This is a work in progress paper. So I really want to test several other propositions to see if there is any merit in this, preferably something that is largely established, for example, so we can test if we get the same results, right? I'm very open to suggestions because, well, that's good. I think discourse is the whole point of this. So I would love to hear if anyone has any ideas. And then the goal of this is also to create some kind of framework to kind of make this process as easy as possible. So far, this approach is limited to hard technical data, right? I'm analyzing repositories, I'm analyzing commit data, but software engineering more broadly really also involves social processes. So I'm not entirely sure if this will be able to encompass those complexities. Yeah, that's it. That's my presentation. Thank you.
Okay, thank you, Kenji. It was really nice presentation and also topic. We do have some questions from Discord.
Cool. I would love to hear them.
Okay. Did you consider any other techniques such as Gringer causality for checking the causality? I don't know if you know this technique. I never heard.
I have not considered any other techniques. I would really like to. There's some very interesting parallels to be drawn between Bayesian belief networks and causal inference. The math is actually almost exactly the same. And I would like to compare things, but so thank you. I will definitely look at this. I'm gonna see if this if I can get this in scope.
Okay, good.
Cool.
Tom also posted the Wikipedia website for that. Are there other questions?
I think so. Go ahead.
Okay, I have some. I'm not sure if I followed this part, but how could we apply your idea in this diagram? For instance, my study, if I have a few data points, because I think you said that it should have, I mean, a minimum large number of data points.
Yeah. So the reason we do this is that causal inference works using the counterfactual, which is the outcome that did not happen. It tries to compare these things. So this is a process that is applied a lot in economics and in medicine and the like. And because randomized trials are very expensive, what they do is they use observational data, historical observational data. And so the intention is to shift towards thinking about what might affect something. So this is researcher input to this. And then given this large data set, again, we want to get comparability. So we have these two groups and we start comparing individuals in those two groups. And in the perfect world, those individuals are exactly the same except for the exposure. That is the effect that we're trying to measure. But in practice, this will not be the case because two clones are different, so by definition not the same, right? So by trying to minimize the effect of other things that might influence our results, we try to get as close as possible to the actual causal effect of X on Y.
Okay.
I think there is a question in.
Yes, there's a question from YouTube. Can you say something on how to go from a simple proposition to a larger theory or theories?
Yeah, of course. So the intention is very much to start small here, but the nature of these causal diagrams is that they are very easily extendable. You see in the medical domain and the like that diagrams build up very quick, and I cannot conclusively say we will also be able to do that, but maybe we will, and I think that is definitely worth investigating. But this is the whole idea behind starting small. If we want to get big, then I believe it is good to first establish these base things, these very small things that we then kind of want to say, okay, this is the case, and then we can build on that.
Okay, good. Any other questions?
Can I ask a question? I tried to click on raising hand, but that apparently doesn't get anyone's attention.
Oh, sorry. Please go ahead.
All right. So yeah, first of all, you asked us to tell you how to make this process easier. And I'm afraid the answer is we have no idea. This seems like a very hard project, essentially. So it will probably be hard. And the question to you is, at some point, I'm not even sure it was on the slide, but it was definitely among things that you said, was that your plan was to get this collection of propositions from all the magic that you have shown us, and then start comparing them to what we already know from let's say statistical research or empirical research, or you know, even Lemon's laws, right? Lemon's laws were called Lemon's laws because there was Lemon who just wrote a piece of text and said, well, you know, this is law number 1. Yeah. And so do you already have, or where are you planning to get this list of known facts that we already know from other places, so that you can compare them and cross-check them with your propositions?
Right. So I think let me say this first. I have yet to find any very small thing that we can all conclusively agree on. I'm sure there's some things out there, but it's been very hard to find that, which I find quite surprising, actually. You know, this is of course very small granularity, what I've shown you, this example. There's also things, you know, something right at the top of my head. What is the effect of code smells on issue resolution time, for example? This is something I think we all to some degree believe that code smells do indeed increase issue resolution time. But
that's a belief, right?
Yeah, I think so. But we can measure that, right? So the point of this is, I think, that these propositions do not have to be true right away, because I think a lot of people disagree with each other, and that's fine. But it's good to talk about this. If I draw a Picasso diagram, or say code smells, and I define that very strictly in some way, and then I say issue resolution time, which is quite discrete, I would hope. Also probably good to discuss about that. And I put that out there, then I'm sure there will be many people who will disagree with me in some way, and that's good, because this is the intention. This is what I want to do. I want to start talking about these things in this very visual, quite simple way, really. And the math and the system behind it is quite complex, I think, anyway. So I want to automate this as easily as possible. So then the responsibility of the researcher becomes gathering the metrics or the data that you want to use. So extracting commit information, code smells, etc., and then discussing about the proposition that you want to test. So I think code smells is an effect on issue resolution time. But maybe you are saying, well, it also very much depends on, let's say, how much experience the developer has. Has the developer been working on this system since the beginning of time? And then we can use this as a confounding variable and start discussing about this. Does this answer your question somewhat?
Probably. I just it's assumptions all the way down, right? So once you start challenging the top, then at some point you say, well, yes, this code smell is harder and this code smell has no no impact on this code smell is actually good. And then you will start remembering what code smells are, and you will find a very dusty book lying somewhere that pretty much also said, well, you know, let me tell you, these are the code smells, and they are bad. Okay.
Yeah.
Yeah. Then how deep do we want to go? I mean, this is already very ambitious, and I applaud every step of it. I'm just wondering where do you want to stop drowning in the sea of assumptions?
So the idea is to go as deep as possible, to go to these very base things that someone has told us maybe many years ago, and then see if that is the case. Because this is my opinion, and I very much agree with you that we say all these things, but many of them seem to lack a very strong scientific background or just conclusive results. And I don't understand why that is the case. And I think it is good that we establish those things. So this is an attempt to do that, which is indeed maybe quite ambitious, but also fun.
Good luck.
Thank you.
Okay. Any further questions? I have. Well, I might have one. Do you have any plans to evaluate these with researchers at some point?
So I'm currently interning at the software improvement group, and I have written a brief amount of text on actually how to, because one of the extra inputs that this causal inference technique needs are these propositions. So far what I've been doing is just speaking with experts on this. People, because generally we do believe things in this field, and that's good because that's a very good place to start, I think. So validating this with researchers, yes, definitely. This can either be, we can get this from expert opinion, we can get this from surveys of developers, we can get this from current literature, current research. This is actually what my example is from. It doesn't matter where it's from. But I do think that currently, as we just discussed, there is no lack of held beliefs, let's say. There are many held beliefs, and it's good to test them, I think.
Yeah, sure. Okay. Okay. Any final questions? Nope. Okay. Thank you again, Quentin. Really nice topic. So I give the floor back to Eleni.
Actually, I will give it to Anna because there's a slight change of plans. So, Anna, do you want to start?
Yes. So our change of plans is that we are going to shortly take you all into the Discord. Everyone seems to feel much more comfortable over there. And before we close officially here on Zoom, I would like to take the picture, the group picture. So ready or not, turn on your camera. And let's take some nice pictures. I hope to catch everyone in here.
Will you count down for a smile or say something like cheese, or what can we expect?
Me?
Yes.
You're
taking the photo.
I'm always calm. I'll count down. Yes. So this is really, oh my God, very. The YouTube camera just hello. Can they? YouTube camera is not switching on the camera. I don't know what's going on there. This is really cool. Okay, so I'll say I hope that this works well. I'll say 3, 2, 1, and hopefully press the right buttons. 3, 2, 1. Cheese from Amsterdam. And just another one. You know, just in case the first one didn't save properly, but I think it did. So again, 3, 2, 1. Kaas from Amsterdam. And that's it. Well, I think that this was enough fun. It was really nice. Good. Thanks for playing with us. We were looking very quickly at some stats. So we had some like 30 participants on Zoom and 39 participants on Discord. So that is actually pretty good. I think having this setup with everyone online did help. Unfortunately, Zoom did not compute the attentiveness score. So that's something that, we'll just judge by the amount of questions that came into the sessions on the Discord channels. And those were many and very nice.
I can also add here the YouTube statistics, which are for today, there were 39 views and a watch time of 17 hours.
That's perfect. Oh, that's really cool. So I guess with this maybe some of these things that we introduced for SATToSE this year could become new traditions. Who knows? At any rate, we hope that you had fun. So the word is now with Eleni.
Okay, so first of all, let me say that there's a small change of plans. So we will close SATToSE now, and then we will move all discussions to Discord to relax, or grab a cup of coffee, and discuss about the many interesting things that we've left during SATToSE, left in the middle. So we can discuss about keynote topics, about some topics that came up throughout the sessions. So now let's close SATToSE for this year. So first of all, I would like to thank the entire organizing committee, especially Anna. Wait, Anna, I have a small surprise. I hope you can hear the sound from my laptop. Yay! So a big thank you. You made organizing this event super fun. I would also like to thank our student volunteers. I would like to thank the Hackathon team. I would like to thank the PC. And most importantly, I would also like to thank you as well for being here. Without you, it would be pointless to hold the SATToSE. So another round for you. So let's see now, what comes next? Well, maybe the SATToSE itself, it's over, but we have a couple of things. So you will receive an email soon enough for the post proceedings. You will be notified about when the deadline will be. And then, as you might know, we'll go for share post proceedings. So keep your eye on your email. You will get a notification the next week. And if you check your email just now, you will also find a request for feedback. So I would like to ask you if you'd like to complete this small survey. We want to know what you liked. This virtual setting has posed some challenges. We did our best to make this event as interactive as possible. But we want to know what you like, what you think worked, and what you think could be improved. So if you have some time, please go ahead and fill out this survey. And with this, SATToSE 2020 closes. Thank you all very much. And we will pass on the torch to SATToSE 2021. Stay tuned, check the SATToSE website. You will see notifications also on social media about what will happen for SATToSE 2021. And again, thank you all for making this event super interesting, super fun. We had some very nice discussions and presentations. So again, thank you for this amazing experience. We're delighted to organize it, and we're very happy after the event. So again, thank you.
Thank you, Eleni. And I also have that.
Thank you, Eleni.
It's my pleasure.
Thank you.
Thank you.
Thanks to all.
Thank you.
So please don't go away. Let's move to Discord. Now it's the fun time. Let's go discuss these fun topics. And I look forward to seeing you all after Discord to the next SATToSE, which will be a